Good morning. Good morning, Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, June 5th, 2021, Saturday. Title of this talk is repetitive one, and that is Civil Engineering, Civil Field Engineering, COVID-19 and in its engineer's role I repeat, designs, construction, methods, contracts, organizations, communications, coordination, quality, and quality, and quality, and quality. Why I am stressing quality? Because talk is quality. Everybody is proud of certificates, and I too have same. But is that enough? If I have certificates, professional certification, academical certification, and all sorts of certification if I have, you can see this certificate designation is elevated one, that is statutory one, that is constitutional one, and here is other one that is also statutory, membership of statutory body, and this is of course international level certification. What these certifications speak, what these certifications announce or notify, or what people expect from persons who have been certified with these instruments. Question arises. These certificates tell everybody that this person who has been certified as such must have possessed certain character, certain execution of roles, that product under this person, whatever products are produced, would meet all those requirements which are specified for this product's manufacturing, and this person would look after all quality issues and production issues, so that delivery made by this person under this person for whatever production or manufacturing or construction would be as required and demanded by documents and by expectations of people, and those products shall perform to requirements, to expectations, and shall please those consumers, customers, etc. Quality system requires customer satisfaction. This is very old term. It has been used for decades. Customer satisfaction is our motto. But nobody defines what is customer satisfaction. You can see quality policy of whatever organization, and you shall find in policy document, though it may be one page sometimes, that our aim is, our target is quality, and that quality target is for customer satisfaction. I don't understand what is customer satisfaction. It should be product satisfaction, it should be criteria satisfaction, it should be performance satisfaction, it should be what money is paid and what comes in return, that satisfaction, or you can elaborate your own satisfactions. Because a person who pays something, and also same person in higher level who pays something, or a person who is very rich, he pays something, or a person who is very, very poor, he pays something. One pays, and everyone expects something different. Richest person won't bother about some money, but poor person shall bother about even a single unit of money. So you cannot say customer satisfaction. It is customer satisfaction being a part of that, but it varies. So quality is something very much, you can say, is very much variant. You may say quality variant. If quality remains constant, it is nice, but definition of that constant contents is different, is exclusive. A product can be classified and is classified into various categories. Okay, brands or categories depending on expenses made on that product and what value it gives to customer. It depends upon pertinent specification meeting which it has been produced. So you will find they say varieties. Yes, varieties do exist in market for every product. You go to shop, they will say, okay, I'll show you 10 varieties, you select yourself. This means you want to buy one of them, two of them, or third of them, or fourth of them. But when you know price, oh, you say this is not within my budget, I can't afford this. Show me second category, and second category also doesn't fall within your budget. Okay, third category. This happens. This means you can't buy product of your own choice due to money requirement. You have less fund. This means it is combination of money and contents of product or specification of product that you are buying, or you may say money is proportional to quality and quality is proportional to money. So quality is not independent, and your budget cannot necessarily buy your expected quality, and your preferred quality cannot be purchased because of shortage of money. So you can say quality is also a shop. It's also a kind of technical business, you may say. Quality is never constant. Quality depends on procedure, and procedures are varying. You specify something and you specify something else for same product. You can augment level of your specification, profile of your specification, and you can find another product. This means always there is boundary for quality. Quality is not free as I think and you think. It's bound by confinement. It's bound by qualifications or restrictions. It is same thing as we say tender. You have to submit this tender with qualifications or without qualifications. Do you understand meaning of that? Tender or bid, as we say, this tender should be without qualification. Do you understand meaning of that? Everybody cannot understand. They may say, where is qualification applicable on tenders or on quotations? Qualification is applicable in education. Yes, that is also one part. But professionally, qualification doesn't mean academic qualification. Qualification means qualification everywhere. Qualification comes from where? Qualifications come for quality. When say quality, you understand that quality applies to materials only, it applies to product only. That is a kind of misconception. Quality and qualification are related terms, because when you say I qualified this course, this means you have quality of that course. You understand that syllabus, you understand that program or scheme. It may be bachelor, masters, or diploma or doctorate, whatever it is. You have that level of knowledge, and that is also within certain limits, because you did not pass 100%, you pass part percentages for purpose of qualifying. And that specification that you have to, that's also specification. You pass 40%, 35%, you get this marks, you will qualify this exam, you will pass this, you will certified, you will be given the certificate of success. This means that is also not 100%. I not 100% are random rare cases, you can say. This is imagination. Means even in your academic qualification, in your academic time, education time, you don't learn 100%. That's why division is made: 30%, 35%, 40%, 50%, 75%, 100%. This is, you are just a learner. Even if you get 90%, you are not master of that. Even if you have master's degree or doctorate degree, you are not doctor of that, because you are partly successful. And that is where quality lies in. Same applies in professional field. No one is master in profession, no one is doctor in profession, despite you have certain degrees, respective those designations of educational titles: bachelor, masters, doctors, diplomat, all that. Those are, again I say, restrictions. You have this level of knowledge, but those restrictions are not police restrictions. Those are not, you can say, it is concorded line. We have barricaded this. There is no barricade as such, because that is representation. If I say I am a bachelor in engineering, I am masters in engineering, I am doctor in engineering, that is only certain reference that he could pass this level at that time or whatever time in life. We can expect this person how much this is level he can deal, but when that person goes into professional working environment and remains there for years, that person gets further and further knowledge post passing that academic qualification. In academic qualification, there is no way that you are exposed to experience, you are exposed to reality of life, because always there is guidance available from your teacher, from your supervising teacher, from your principal teacher, from everywhere, or reference teacher. You will find support. You would not work independently, but in field of profession, after a few years, you have to work independently, because you are responsible there, you are in charge there in your field. In whatever field you work, you have certain level of competency generated by virtue of your formal training and your experience, and generally that is called expertise. Expertise a qualification, expertise a kind of quality, that is also classified. You cannot say every expert is same. Every person who has been defined expertise or granted expertise, certain expertise or professional title is given to someone, even doctor or engineer or to advocate or to work with chartered accountant, they are experts also in classification. Means again their professional competency comes into picture, it comes into play, and expertise is again defined. If you have this level of competency, you are entitled this. You are having this level of competency, you are entitled this. Like in every field you will find professions, every profession, this level of engineer, this level of engineer, this level of doctor, and this level of chartered accountant, and this level of advocate, and this level of professor or teacher, or this level of this and that. In every field it happens. So you can say quality again is a restriction. In fact, quality is qualification, because qualification means restriction on individual or on document. When, as I said, reference of tender or bid, that you have to submit non-qualified bid or free bid, you can say. This means whatever is defined there in tender document, you have to comply with that. whatever is that. क्या हो गया? You have to define in tender documents that whatever is given in tender, whatever is mandated in tender, one has to comply with that to submit that bid. That bid must be submitted in compliance to all conditions and all provisions of that bid or tender. And that means there is no freedom. There remains no freedom to bidder, no freedom to tenderer to alter any condition that is included within tender documents. And that means that bid, that offer is known as free or compliant. Tender is complied with. That means that tender, since that tenderer or bidder submits that one, is without qualification. But if same bid is submitted with certain modifications or with certain other conditions, written separately or expressed separately, condition is this, if you give me this, I will do this, or if you do that, means some change, some alteration, some modification, whatever kind, contextual modifications or technical modifications or design modifications. If a tenderer does that, and it is clearly written in documents, in conditions, that that bid shall not be accepted. So what happens if tenderer intends to submit bid? That tenderer has to submit two bids. One is without qualification and one is alternative bid, and that is with qualifications. So both are there. Generally in advanced contracts, in EPC contracts, engineering, procurement and construction contracts, or EPCI contracts, PIC contracts, such conditions apply. You have to do both bids. One is according to documents and other one is according to your proposal. Both are submitted and then scrutiny is done. So it's life. Qualification, as I said, is restricted, and qualification, we say qualify, here we say qualify, both are same. Qualify or quantity, or you can say qualify. Qualify means a kind of quality verification. Same way, quality means equal term. It is having certain qualification, and that qualification is work qualification, performance qualification, contents qualification, composition qualification, or you can say design qualification, or you may say material qualification, material variation, material composition, design variation, design composition. But all are acceptable depending on these, because if there is a material change, it costs. If there is a procedure change, it costs. If there is a durability change, it costs. If there is a service condition change, it costs. If there is a safety change, it costs. Means there is no limit. In fact, there is a variance in profession, and all are acceptable in proportion to budget and cost. So we can say quality is very simple to be defined, that standard of quality has variation cost wise, time wise, contents wise, and it's program wise. Means you can think and define. Therefore, quality is not a general word. or you can say it applies everywhere, depending on situation, depending on circumstances, depending on requirements, and depending on acceptability. And that is where we have to understand every point. Every point must be clear. Quality is not a straightforward world. One level of quality in some project which cannot be accepted in another project, rejected there. It doesn't mean rejection on that project means rejection on all projects until it is rejected generally in specification definitions. That is the reason that specifications are included on every project. Some are accepted on one project, some are not accepted on other project. Similarly, conditions of contract are variant. Conditions of contract are not same on all projects. They say general conditions, they say specific conditions or particular conditions, or they say other conditions. Means so much so is available, so much text sometimes is available in such documents that it's a kind of big subject of engineering or that field. When you see documents, you will find hundreds of pages in volumes, then many such volumes, and you will find hundreds of pages of drawings and also hundreds of pages of specifications, and you will find a big volume on major projects. You cannot even go through those documents in one day. It takes months sometimes. Yes, you can go preliminary on those subjects because you are experienced one and you can start with the understanding of part documents, but you have to study all documents. Of course, there's a system, there's a class, and you can say this type of tender must have all these details. You can go to details and understand to start project, but it takes time to thoroughly understand what this project is, and that's time when tender is done, bidding is done, or you can say when you understand, you try to know what is required in this project from documents. But it takes time to go through them, and of course experienced persons know what should be in that and all, and that's the reason the standard documents are prepared, standard codes are available, standard designs are available, standard sections are available. For purpose of repetition it is, for purpose of repetitive requirement it is. We cannot blankly do something, we cannot plainly do something, we have to understand what is requirement. So I am again giving you stress to know quality in different mode. Quality is above all, I can say, because we have design level, we have design line, design time, design program, we have can say planning program, we have tendering program. Every project has every division, and all those depends upon original work, and that original work, that is also relative original work, it's not basics original work, and that is called design. Design, which is very prominent discipline in engineering and everywhere. No good design means no good work, but every design is good, because when you design something, contemplation is done, imaginations are done, or you can say requirements of those who require you to design, those are met. So it's also relative to others' requirement, and those others' requirement are also relative to other requirement. It's a chain, you can say, it's like a perpetual arrangement, means there is no end to that. You start somewhere and you have to reach back that way. I start from some design or specification, I have to comply with all requirement of procedures, and then at the end I say, oh, I have met this requirement. This means that requirement which was at start, you have come back to that, and you say, I meet here now. This means that circle is over, that circuit is over. That circuit is very important. Everybody comes into that circuit. All stages of projects lie into that perpetual action. Just like we usually say perpetual arrangement, solar system is running in perpetual way. Individual perpetual movement and solar combined total movement all are perpetual. That's why they never end. They never strike together, but effect strikes. You try to understand what I'm saying. Quality cannot be defined in isolation. Yes, it is used in isolation on projects, but it's defined everywhere. So, what actually is intended here to let you understand quality first you should have means a person who is involved with quality work to produce products, the products founded on some quality, products that are possessed with, that are inculcated with, or that are, you can say, what should I say, those are produced in such a way that all defined qualities is inducted into them fully. Those products are named accordingly. Somebody says this is a brand name, and that brand name tells what standard of quality it must have. And if does not have, that brand is diminished, that brand is given no value, though it's branded, they say. But branded doesn't mean quality. Quality means even there's no brand, it can have quality. It depends how it was manufactured or constructed. So quality required everywhere. You can say even in your thoughts quality is required, in your writing quality is required, in your manufacturing quality is required, in construction quality is required, in every other field some level of quality is required, which is a must. And particularly in engineering, which is a solid field, it is not imaginary field, but it's field that changes, that transforms imaginations into practicality, imagination into mechanical work, imagination into physical work. This is that kind of profession, or you can say not profession, but a kind of commitment or kind of religion. You should say faith, religion, applied. One has to be professional only when can you dip into that environment. Professional means you have to devote to profession if you want to serve profession. Devotion doesn't mean you worship that, but carrying out work according to professional requirement is also called worship. Only difference is K. In worship we say WORSHIP, and in this we say workship, that is WORKSHIP. Workship is important, worship is not important here, but we have to prove that we worship this profession, we worship our job, we worship our demand. Just like a doctor worships when treats patient, that's also a kind of worship. If I give good quality work, I comply with quality, I think for people, not for person who is spending money, but person who is going to use that product. That person should stay safe in that. Our products, we are civil engineers, our products are permanent. Again I say, this point you have to understand. Only engineering in world is civil, which gives permanent products. Permanent means until at least you are there, you will use it. Your generation may use it. In civil engineering, if you talk of permanent works, these may live up to 50 years, 100 years, 150 years. This means these are forever for you, because nobody can live up to 1 million years. So in your lifetime, you will see that, and in your kids' lifetime, they will see that product, use it. So that level of existence of projects can be called permanent one. In mechanical engineering projects or products, in other engineering projects, you will not find that level of permanence. That happens only in structural civil engineering, construction, civil engineering, you can say design, civil engineering. Civil engineering means it's omnipresent. It's itself God's work. Why I sometimes compare civil engineering to God? Because it is God who created civil engineering. Creation of this universe is a part of civil engineering. Though there's no RCC in that, no structural steel in that, but something is there which cannot be understood by human being. Whatever qualification do you have, whatever level of knowledge you have, still human is not that much competent who can produce such solar system or such universe which is still beyond imagination. Forget doing that. So we can say we have limited engineering, we have not free engineering. Engineering is limited, just but that limit is also not able to be delivered. If we can deliver defined limits, we can do a lot. Yes, it is delivered elsewhere. For example, if there is no quality in flight in aeroplane, if there is error, that flight will crash, will not work. If there is error in some engine of car or truck, it will not drive, it will not move. Same way, if there is error in mechanical designs, which are very very minute applications, that machine part shall not work. It happens. Accuracy is more important sometimes, and quantity is also important. Fitness is important, circuit is important, integrity is important. Only then some product works. That is, you can say, mandate, that is requirement in all those engineerings, that mostly where fitness is more important, where you can say if an error happens, those products cannot survive. They are either short circuited or they do not fit in, they cannot perform, and they cannot move, or they cannot produce something. Those are actually life based projects. You say this product has 5 years life or 10 years life. After that, this is obsolete because of technical change, because of technology change, and that technology is obsolete and new technology comes in, or modified technology comes in, which requires another design for product. So you can say those products are having variance of qualities. Quality keeps on changing from years to years on those products. New formula, new technology, new requirements, or you can say new arrangements come into existence, and old ones are obsolete. They become obsolete gradually, and we can say, see, there is a change. It's because of technology. Example is now changes on mobiles, changes on other equipment. You'll find that whole world changes from manual state to mechanical state, and then to electronic mechanical state. Like that, in future we do not know what we shall find. So quality changes from one level to another level, and that's why we say engineers change always. It's not only engineers change always, engineering changes always. Education of engineering change always, but basics still remain same. That's beauty of engineering. Basics still remain same, and generally speaking, to my understanding, there are 3 branches of engineering which never change, or which change accordingly after long term. Civil engineering, mechanical engineering, and electrical engineering, these are family engineering, you can say. Civil engineering is basic family, prime family, because even if there is no electrical current requirement, there is no machine, civil can perform. Okay, it doesn't have light in that, it doesn't have machine in that, but it has structure, it has ordinary structure, maybe mud structure, we can live in there. It may have stone structure, we may live in that. And that is what used to happen in our ancient times. We call ancient times, but at that time it was not called ancient times, because that was modern time at that time. So you can say, even though there was no RCC, there was no precast, but hutments were there, structures ordinary were there, and people used to live. There were no water supply. People used to go to wells or used to go to rivers and take bath. So it was also civil engineering, though maybe it was not named, or no university was available as such to deliver such students or engineers. But it is historical time, it is evaluation. It's also evolution now. Evolution time never stops. Maybe after 100 years, 200 years, people would say there was a time in 2021 it happened, that happened. People would talk that way, and this will become history. And something else would come, and that also would be recognized, that also would be accepted by society. It's therefore a very important point. I've not started yet to scan or to move on my documents. Quality required everywhere, and that is basics. I can say that I should close certain files of this. Of course, I can say I should close certain files so that my okay. So I say quality required everywhere, and quality depends on time, quality depends on advancement, quality depends on technology, quality depends on, you can say, requirement. And quality, today's quality is not same as tomorrow's quality. Quality is time dependent, advancement development, requirement development, dependent on all such future use. Maybe tomorrow something happens and you will find something new and you will use it, because 200 years back or 100 years back you could not imagine there will be some carrier that will fly in air, but you got aircraft. Same way, might be many hundred years back nobody knew there will be train, but you got a train. That way, because these are human related products where natural material is used by human to produce all these. But remember, human cannot produce human on its own. Human still cannot produce solar system on its own. Forget, human cannot even produce earth construction. Impossible. Human is not able to understand in totality what is our earth, what is our solar system. Human is in search of that imagination which is totally beyond control of human, and that is weakness of human. Where human stands, about that human thinks very little. Human always thinks distant location, objects, but that doesn't work. First we have to see where do we stand, where we live. We have to see first that one. And then I have not seen total science of earth. I have not seen totality of geology. I usually understand with limits, because geology is high profile science, but it is not developed well. Geology is very much science that civil engineer has to understand. But problem is that civil engineers rarely understand this, because this is first of all not text, this is not numerical based. Problem is that in civil engineering particularly, people want to solve numericals. Numericals means engineering problems that are defined in questions, not in text form but in calculation form, because engineering backbone is calculations, formula, combination of formula, derivation of formula, application of formula. Engineers feel very happy to solve numericals and find answer, and actually that is design basis. No design can be done. Designs don't require long theory articles. Designs don't require writing essays or writing, you can say, novels or translation and grammar. Designs require thorough knowledge of what you have to do, and that too is step by step, stage wise by stage wise. Design is hard and high profile work, because this is only way, this is only procedure that takes you from raw material state to what you expect that material to serve for. That is, you can say, objective of design is to go to that, you can say, constructed or manufactured product which would serve someone, or which we use in production, or which is to be used in permanent objective creation. That's engineering design. And when we say design, this means not just formula application, that is total process study and application. Design, people say design is quality not related. They are right too, because they don't understand design. They understand only product, they understand only procedures of manufacturing, but they forget design is applied, and that is called manufacture. Design is applied, and that is called construction. So it is design only that is to be converted to physical material, physical product. Otherwise, we cannot do anything. So design is very much important as construction is, as production is, because both are same. One is on papers in minds, and that is transformed into physical world or material world. That's called project of production or project of construction, and that project becomes permanent. It is converted to use, and not just for manufacturing or production. Whatever material, whatever product, whatever structure we get, it cannot answer you in one day how good it is. It takes some time. Sometimes it takes years together in construction, products, buildings, houses, structures, that this is good, this is done according to requirement, or this is not done, because you shall find defects after many years. Defects, such defects which should not result in, if that quality defined level is accepted, is complied with, and is that product is induced with those requirements. So quality required everywhere, in engineering particularly, which is a must. And if some engineer does not do that, it may be contractor engineer or supervising engineer or others, then I can say those engineers cheat themselves, those contractors cheat themselves. Okay, contractor has to make money, but money making doesn't mean you cheat someone. Money making doesn't mean that you play with lives of people. It doesn't give authority, such authority that you violate qualification, you violate quality requirement, you violate your basic duty. So in engineering particularly, because engineering is related to whole world. It's related to whole world. Without engineering, world cannot survive. That is also true. If there is no engineering, you will not find even electric current supplied to you. If there is no engineering, you will not find any equipment in your home. You cannot find anything if engineering doesn't apply to you. Maybe you know that or you don't know that because it's life. Sometimes you use something and you don't know you are using that engineering, right? So if I'm not talking of those who are not qualified engineers, but I'm talking of for those who are qualified, experienced engineers, that they have a role to play everywhere. Role in every section. For example, role in health sector, role in safety sector, role in design sector, role in, you can say, planning sector, construction sector, manufacturing sector, or quality compliance sector. Everywhere it plays. Only then you get something delivered. Otherwise, it will stop. Means you have to satisfy every section, every division you have to satisfy, and engineers have capacity so to do. It is only engineering education that can create something. It's only health education that can treat patients, treat not only human but also animals. So other sectors are not directly related to life but results of others' lives. One should be happy that one does in engineering field, whether in design or in construction or in manufacturing, doesn't matter, because expertise is required everywhere. Design is not experts only, construction is also expertise, and you can say other divisions too are expertise, because you have to do many times all acts, and only then you know plus and minus, merit and demerit, or what requires to be modified. Otherwise, you cannot know. So who shall tell us? Nobody will tell us. Nobody. It's only self-telling. I have to tell myself, and I can tell myself only when I talk to myself. And that is procedure. If I can talk to myself, of course I am in isolation. In group, there's no group. I am there, and I talk to myself. There's another entity within me to whom I talk. So in fact, I am not alone. There's a room I'm sitting in, or there's no room I'm sitting outside, but I question myself. Believe me, those who question themselves are brilliant people, are intellectuals, are problem solvers, because you have to find problem yourself, and there lies use of your intellect. You can discover problem yourself, but that cannot be done in physical groups, because intellectual science says, intellect says, you use your mind, you can say, very commonly and very specifically both. Common is identification. Common means you are not too much worried, but you have to comply something. But you can say, what is compliance? Yes, it is too easy. You do what is required to be done, and that is compliance. There's no way out from that also. And if it's not complied with, it is called non-compliance product. Non-compliance means what? Non-compliance What do you mean by that? That's also a question mark. Non-conformance means it is in engineering, also it is everywhere, that quality non-conformance product is called substandard and therefore rejected. Non-conformance means engineer is either careless or ignorant or incompetent one and therefore redundant personnel. That is a result of non-conformance, and it is very serious document. If you have issued or you are issued non-conformance document, that is called a report or a complaint, or some document is given that your product, your work, or your this item doesn't comply, doesn't conform to requirements, that is called NCR. This means non-conformance report or non-compliant report, which is equivalent to rejection until that conformance is achieved. Non-conformance means incompetency, you can say. To that extent, this product is done, not general incompetency. That point you have to understand. So we can say we must change to requirements. We must do requirements. We must change to requirements to achieve intended quality standards for universal recognition. Quality requirements checks being a must, missing which we have to blame ourselves for quality failure. Engineering means quality application. When you say application only, also means it includes quality. Not necessarily this quality application, you can say it's application, which means quality is a part of that. It has taken birth in quality, it is residing in quality, and quality cannot go out of this. That state we must achieve. And if it is failed, means quality has failed. Engineering means quality application and continuous improvement of quality endlessly. That's also a point. So engineering is different. Engineering is never constant. It's never fixed. Stage-wise, time-wise it's fixed. And when there's change in technology, engineering changes. Again I say, thinking is your job. Thinking is your solace. Thinking is your mind. If you cannot think, then you do not do job. You cannot do job. Engineer never ever does job if one says do it. No. Engineer says to engineer itself. If I am an engineer, my own power would tell me I have to do it. Of course, it should be my right to do first. So if I have to do it, I am telling myself I have to do it. Same way you shall tell yourself to do it. This means you are not silent, even if you are not speaking much. You are not silent. That's the point to be considered. Silence or no silence. Engineering is no silence. Engineering speaks in silence. Can you understand this? Engineering speaks in silence. Thinking speaks in silence. Thinking is your teacher. Thinking is your guide. Thinking is your machine of thoughts. Sometimes this is school of thoughts. This is not a school of thoughts. It is a profession of thoughts, life of thoughts. Thoughts are your guide. Thinking is your guide. And that is where you have to live with. Analysis is tool, as I said before many times. You have to accept that. And if you don't accept that, it's your problem, not my problem. If you don't accept that. Because what I say, analysis. Let us understand article of this. Do you know article meaning? There are always minimum two meanings for every verb. One is its applicable meaning, and another is its meaning that can be understood from its contents, its word structure, its article structure. I say analysis and say analysis. Analysis. Somebody calls analysis, somebody calls analysis, whatever you call it. I think calling is not an issue here. That is a different subject. I'm saying analysis. 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 What does it mean? N, okay, is used with vowel. Forget N. Ally. Ally means what? ALY. I say it's my ally. This person my ally, or I am his ally. This means I am related to this member, or this member is related to me in this group. So we are allies, right? So when I say ally, I have to be allied to some question, to some issue, and issue can be structured first. We have to understand the structure of every act to do. That structure's understanding is alliance. You have to know what is there. For that purpose, you have to find ally's status. I am ally, and that is ally. That's why we both are, operating together in procedure of thinking. That's why we are allies. Means I have to know how many allies are available in this problem. Then I have to come out with each ally and find solution for each ally. This process is called analysis. Analysis is not simply term, it's a word. It's a word, another word. It's called intellectual word as well as called engineering word. Because engineering cannot be done without analysis. Analysis is engineering. That point we have to understand. Nothing can move without engineering, and analysis means origin of design. Analysis is design basis. Without analysis, no design can be done. Without analysis, no problem can be understood. Without analysis, you can say you cannot do any project. You cannot do any design. You cannot do any construction. Everywhere, even to find quantity that you are going to use, that is also based on quantifying analysis. You have to understand everywhere, in all stages of some project, what's going to happen, how much material shall we need, at what time shall we need, and that is detailed analysis for quantification. Because it is quantity that only goes to project, and how much quantity has to go, that analysis would tell you, and generally it's called quantification, and it's called takeoff and quantification. This material quantification is converted to cost value. So analysis is great procedure, it's great formula, it's great mechanism to use your mind so that you move at every point nearer to your objective, and that is really important one. So what we say then, just like it is construction method statement, can there be other statement as well? Can there be? We have to ask ourselves. We have to think on that. Yes, there are. It's not construction alone that is method. It's designed to that as method. Every item is designed in construction, in engineering, has methods. From simple element to very complicated mechanism, methods are available, and those methods are mathematical applications. Mathematical use, all mathematics, all subjects in mathematics are used in engineering. All, whatever is there, and without that you can't move. It's not necessary that you have to define every calculation. That calculation also lies in your minds, or it can be worked out, it can be sorted out. So that is different time, different case. So what we say, our methodology lies in designs as well, though it is defined one. If there is not defined one, then we have to define ourselves. How can we reach this solution? And that solution is also not difficult if you understand technology, if we understand our subjects. So method statements are also applicable in designs, and of course for sure applicable in construction or manufacturing. This cannot be isolated. Means when we say designs, means design everywhere, small item or big item, it applies everywhere. Yes, if you are only committed in designs, you are dedicatedly employed as designer, that is different. Your life is design. It's up to your opportunity how to do. But I understand design cannot be given into inexperienced hands. It must be done by experienced people, and that is where reality lies in. So I don't want to take more time on explanation of quality theology. You may call it theology, you may call it mental requirement, or you may call it by whatever name, but essence doesn't change. Essence remains same, and that essence is essence of mind, you may say, essence of character, essence of quality, essence of production, essence of manufacturing. We can say engineering is a different world. Engineering doesn't mean being an engineer, even though engineering is important for engineers, but it's hardly, I think, 1% engineering people who are involved, or few percentages you can say are involved in engineering designs and engineering production. But others are not engineers, but they do engineering also. All crew members, all staff members who are linked to production, manufacturing, or construction, they're all directly linked to engineering, though they are not engineers. But they are, you can say, item engineers, or you can say procedure engineers, or you may say they know a lot about their work, they know a lot about their discipline, even if they are not engineers. But by virtue of experience, by virtue of maturity, they have good knowledge, they have sometimes extension knowledge of these activities. So we can say that's also a kind of quality that we have such people. Once I raised a question in some seminar, this was safety, health and environment seminar, and I just raised some question, why not to, it's a question of civil engineering issue. I said, why not to use start cards for all these excavation activities and other activities? So the response of that speaker was that people in civil engineering are not that much literate level, whereas in mechanical and electrical where people are little educated. They can understand what is start card or what is job hazard analysis, but everybody cannot understand. I had some, requirement on various items. I got a mail also from Institution of Engineers, which mail is addressed to all corporate members about issue of role of engineers in COVID-19. It really was, I never expected that such a mail shall be sent to all members. I'm finding that there's no interest in engineers. And there's no interest that is shown about what is COVID, how it can be understood, how it can be fought with. These engineers have not, reported anything or suggestion they have put in public on various social websites. You can say web media, social media, we call it. Thousands use social media. Generally, all engineers use social media, and not only social media they use, but also, websites. They write a lot about profession. There are so many such platforms. But I'm not seeing, you can say, even by error, some proposals, some recommendations from senior engineers about COVID-19. Maybe a thought has developed that COVID-19 is related to doctors and scientists. On what basis engineers are involved? It's good understanding, we think that way, but fact is different. It is problem for human. It's problem for entire humanity. So human means engineers also humans. They have every right and duty to involve in issue of COVID-19. But no, it didn't happen. I write many times. Usually I write something, if not everything, something about this issue. And I feel pleased, at least considering myself or being a part of society and being literate, and of course on top of everything being engineer myself. I have to understand what this virus is, not medically but generally, and I try to get information from various sources, from research papers of doctors, research papers of the scientists. If you keep in touch with news or with reports, you will find that information comes to you and you have to track that. If not track at least remember that. And that's way you can find every hour something new in our field. And that's very important part of involvement. If role of engineer is not defined in COVID-19 situation, it doesn't mean that engineer has got no role. I should say, of course, this is medical world requirement, but we are also part of world, and we can understand better what's meaning of role, what's meaning of description, what's meaning of all that. We have to understand this clearly. Yes, it is medical issue, it is health issue, but health is also engineering issue. We say safety, health and environment. If we cannot do this, if we cannot apply health part in engineering, you can resolve it. You can't resolve anything. We know that this virus has impacted billions in a way that millions have been contracted by virus him. And till today, there is no solution of every such, say, every act of this. We could understand, we could know, but I think we are carefree. Life is so busy, it has been so busy and occupied that shortage of time exists everywhere. I think so. I know it's not, but let us say, in respect of those who don't have time, if we don't have time, we can't think of that. If we don't have time, I don't understand what does time mean here. Time has no meaning here. We have to understand that point. COVID-19 role is very much direct in engineering, and that is, first of all, we have to analyze where is engineering part in that. There is an engineering part, very much engineering part in the virus, and we will discuss. We'll discuss that because that is very brief discussion, and I want to start my technical work now, very much technical work, and that is quality requirements. As I said, I have gone through this paper to you for many items, and you know what items are. I'm not going to repeat that. In statements here, we have here these statements. Suspended slab work has gone. I think I was here somewhere. I had done raft, I think I had done diesel foundation, I had done. I was on fair face we had done. Yes, before that I start this, I have to deal with some items. Frankly speaking, there are some items I will deal with. Let me see where those items are. This is, I think, the method statements column. I had photographs of something. Let me see. Tabletop, Rancor hoodie blocks. I think this is important one. I'll open this file as well for you. And also I have to open for you this file. House plan, ground access, column, forms, cover slab. Also I have to open for you because this is also very important to discuss with. And also I have to start one more. I think that is OD slab. Slabs there, and tabletop, tabletop sketch. Before that, hoodie is I am finding house plan, ground side, house plan, hoodie slab, hoodie block. So hoodie slab, I think. This is what I would say. and I have to print it is better. Print this one and so that you can see this. So this okay, this is coming. Save as. This lab. This lab. So there are some here. I'll go through that one and I'll be back in say 10 minutes time. So quality PDF, quantity requirement and curly, okay. Hoodie saving, and this is regular hoodie. This is hoodie slab. holy slab. Holy slab I'm showing to you, and before that I'll go here and show you this block. This is masonry block. This is masonry block, but it is called hoodie block. It's called hoodie block, and I could not show you these dimensions because that file is not available. But here it is dimension. You can see that's different one. Single color, well, color is not the issue here. Product, product dimension, as it says, product dimension. You can see that technical details, unit weight, compressive strength. This says 420 380, 200 200, means this tapered one 420 380. It's all same here, and one is 18 kilo, one is, that is 241, 22 kilo, and other one, higher one, is 425 kilo. Compressive strength is, that is 3.2, 3.2, 3.2 is Newton per meter square. It's not block capacity. Strength, it is concrete strength. This means this is only for block work. This is not for load bearing. It's for support only. Product technical document you can download from us. I'm not interested in that. So you can say it has, then I think nothing technical here. It's only commercial. So we go back. Purpose was to show you. It's clearly given in my what was written that hoodie blocks are also called filler blocks. They are used as infill in construction of concrete floors or roof. So infills means not structural units in concrete floors or roof slabs, ribbed slabs, to make slabs hollow, which improves thermal and acoustic properties between floors. Hoodie blocks are fire resistant as well as resistant to weathering. Such blocks, which boost sound and heat insulation capabilities, are produced in all standard shapes and sizes. Filler blocks of higher strength than those specified in technical details can be produced per specification requirements. So you can say these are blocks hollow, not exactly through hollow, but based hollow. This is hollow portion, and if you see inside, there's a cover up. So only hollow exists on one side, not on all sides. And if you see how it is used, I can say how it is used, then this is that. And before explaining this, I like to go here because I want to close this file. You remember I put one sloping slab issue, how we have to pour sloping slab, and this is there. If you see this, first this diagram, it's a sketch, you can say. This is what I can say is room like this, and there is, if you say here on this sketch for something, I think it's reverse one, there's two different no problem. You can say this is actually, I copied from here. This is slab, this is stair, this is a stair cover. Stair cover is a plan you are looking at. This is stair cover, and these are some teeth created in architectural way. These teeth are horizontal. This roof, two parts, half this and half this. These are sloping roof it is. And if you find section, though it's reverse, no problem, but this is that slab, and this is teeth, and this is section of that. We'll see how to show it to you. That's the way it is. It is that, this is roof, and this is teeth, and this is inclined slab. You can see this is slab. This is dimensions are shown in this for your reference only, not for my reference. And I'll go to my reference now, which I will show you. And that important point is this. So I'll take it reverse because and this is important one, only then I can see that is here what I have to see. So maybe it goes up. Okay, it has gone up. Yeah, this is it. You can see this. Now what I said, this is all horizontal, this portion is this portion. I've shown a half portion for this formwork. I'm not showing formwork on this. Both are sloped on this and that, and this is around 40 degrees Celsius. Now what is after all requirement is this portion is this. You have to pour this portion. Because angle is more than 30 degrees, I don't recommend you pour directly on one, keep one form here and keep its unformed surface. Generally, if it is less, it's around 30 degrees or less, we provide formwork only for soffit, that's underside of slab, and not on upper side, and we call it unformed surface for concrete. Okay, that's fine, unformed doesn't matter, but usually it happens if you have horizontal slab, we call it suspended slab. This is also suspended, but this is different than suspension. If you sit on the suspended slab, you just do formwork of bottom of slab or soffit and edges as well as beams, vertical and horizontal sides. It's enough. You have to leave upper side of concrete surface open and you finish that surface. You don't finish bottom surface or soffit, it's automatically finished. Here little difference we have to see for pouring, and it's actually physical understanding. It happens on sides. If you can say, you may say these are all these are battens or scantling. You can see these lines, battens and scantling are these, and this is here. If you see, in this case, you see here, this is slab, proposed slab, and this is your timber plate backing, and this cover backing here in this case, and these are all various structures. What happens is these lines, or you can see these lines coming in from projection, your cover surface top and bottom are covered by these forms at soffit as well as on top. We have to pour this slab using cover. That's the only difference, because if you pour directly, concrete may not stay there, it may come down, or we may not be able to do compaction of concrete, vibration of concrete. For that purpose, we have to plug this, and we have to leave some areas open to pour concrete and vibrate. In fact, if there are so many plugs, you can say, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 in one row. And similarly here, 16, about 64 plugs are there in shutters and formworks on cover. But how to pour? Only way is practical way, that is done on sides. We will discuss later also on swimming pool. These plugs, now we have to keep some areas open like this one. Don't keep all open, not necessary. If we wish, no, it's not possible, then we can keep entire row open. But let us see, I keep on here and here. Alternatively, I have not shown here, or here. Same way, I have shown here and here, but it is also here. It may be here, it may be here, depending. This is lower portion. There is no need, because we have to put some stopper here, or we have casting with this horizontal portion. In that case, there is no need of stopper. this will automatically act as stopper, because we have to pour this portion first in this case, and then we have to go upwards. This is usual method. So when this concrete is laid here, automatically this will become a concrete stopper. So we have to pour through these openings. This opening we pour, maybe we have opening here. So this opening is poured, this concrete will come down to here, and also you can push in here. Or if you wish it's not possible, then you can put one opening here as well, and you can directly pour. Vibrator can, it is only very small, vibrator can, a little inclination move here, from here little inclination can come here. When you pour with pump or something, automatically when you are using this boarding on unformed sides, there is no risk. You can allow plasticizer, and you can pour into this portion. From here we move down, and we may go here this way, and you continue this pour, you move this way and this way, this way and this way, and you can vibrate, right? And this will go this way as well. When you go on pouring, and when you see that after 2-3 vibration application of compactors, this concrete comes here, means this has been filled, and you can apply more vibrator, and you can see same way it now happens. And also if you think that there is some doubt here, you can put these holes here, so from here also you can control from here. This is purpose of pouring of concrete. This is just indicative, I'm telling you, because I have not started pouring of concrete yet in all these statements. I'm just giving you preparatory works. So I'm explaining here, I explain here only for preparatory works, and form work is preparatory work, reinforcing bars is preparatory work, and this was very important for sloping surface. Though this diagram, this sketch was for 28 degrees, but I changed and got it 40 degrees. And this is method, we can say, working method, how to pour concrete. This is what I had to say. This is some kind of a method, a kind of method statement that works for this. So I can say that we have now to, this is method here. I understand you got it. Middle ply is written, middle ply opening alternatively. This is I am considered as middle ply. This is not middle ply then. Ply opening alternatively all over sloping area, all over sloping slab. This is there, and also we can say, I think I have written here, top ply opening alternatively. And this is what is important in this. So this is one part, this is common part, and then I can say, if you go to body, now I close this, okay, I think it's fine. If you go to this, you will find this is some, you may say, what is this? Somebody may ask me. Actually, these are blocks, these are blocks. You can see these blocks are put in here. Same with this. It's not full sketch, and in these blocks, in the design in such a way, this beam should be accommodated, this beam should also be accommodated, and this beam should also be accommodated. Wherever structural beams come, should be accommodated. This is heavy reinforcement. It's not ordinary small diaby, but it's quite structural reinforcement. But only replacement here is type of shutters, type of formworks. Means these blocks, body blocks, have been placed in to constitute permanent formwork or lost formwork, not withdrawal or you can say striking formwork, but to remain in place forever, permanent formwork. And these blocks are not ordinary blocks, as I said. These are hoodie blocks, and these are like this, and you may say this shall be used in such a way that we use these hollows. I don't have complete details of that, but generally, services move through beams, you can say these moves through beams, you can say here you can provide services in these beams. You may have to provide concrete, you can say concrete, or I should say, say conduits, electric conduits are through these services which are in hollows between blocks, or say beam hollow within blocks, services will pass into these. Of course little problem there, but it does. Or when you place blocks, you can say there may be cavities in these blocks. In certain cases these cavities can be used for that purpose as well. Not necessarily that if these blocks are placed in such a way that there may be space between these blocks to provide. These are not closed ended. If both ends are open, and these services can come through beams and pass through these cavities or through these beams, depending how it is. Generally it's better if these go through your hollow cavities. And also if you need, if for example this plumbing pipe is, yes, it's gone in beam, though it's not recommended, but there's no other way what to do. So it can go in beam as well, and as far as structure is safe, it doesn't harm that, but not necessary. And you have to provide some opening here, which you can provide AC duct opening or some other opening, and depends on designs. So just for reference of that, I tried to project to you this reference from I taken from some site. It's not my reference. And also you can say this one and this one, this is hollow blocks, and you may say I can close this file now, no need. So go to now is the checklist for RCC hoodie blocks. Checklist for RCC hoodie blocks based slab work. Hoodie blocks. This is a website, you can see yourself. This is hoodie blocks, and this is another one. I've taken references from that for information only. Hoodie blocks are also called filler blocks. I just shown you that from that manufacturer. These are used as infill in construction of concrete floors or roof slabs, ribbed slabs to make slabs hollow, which improves thermal and acoustic properties between floors. Hoodie blocks are fire resistant as well as resistant to weathering. These blocks which boast sound and heat insulation capabilities are produced in all standard shapes and sizes. Filler blocks of higher strength than those specified in technical details can be produced per specification requirements. So this is, manufacturer's recommendations. Not bad. If you have this, means nothing wrong with that. Hoodie blocks are also filler blocks, and they infill. We use infill. We use them in infills in construction of concrete floors or roof slabs, ribbed slabs to make slabs hollow. Hollow means improvement to thermal and acoustic properties between floors. You can improve thermal properties, acoustic properties because of void, because of thickness slab is made of. Hoodie blocks are of course fire resistant as well as resistant to weathering, which these properties boost sound and heat insulation capabilities, and they are produced in all standard shapes and sizes. These blocks of higher strength than those specified in technical details. So, and it can be produced to whatever size with the specification. 4D precast concrete trapezoidal blocks. Trapezoidal means because they're varying dimension. That's why I'm calling it trapezoidal blocks. 4D precast concrete trapezoidal blocks are used to be laid at low blocks to blocks spacing. Checks for all items. Checks for all items should be made for various vertical members as described earlier, namely neck columns, suspended slab, soffits and sides. Ensure for good quality 4D concrete blocks of defined dimensions are procured. Ensure that cut size blocks to suit site requirement are procured. Ensure that slab formwork is fixed on scaffolding system as usual. Got my point. This is very important. Slab formwork is fixed on scaffolding system as usual. Whole slab area is to be laid in one level without allowing any downstand beams formworks. There is no downstand in this because all downstand are available within this slab formwork and between these body blocks. Check setting out of beams to be laid between these blocks, lines in both directions to conform to design requirements or were shop and working drawings. For the building, okay, check that 4D block works are carried out correctly to be laid on set out lines. Check for adequate vertical space availability for receiving thin slab to be laid cast in situ concrete for allowing diaphragm action on horizontal system. What is head system then? Actually, this is just permanent shutters. I think that's important. And this depth of so is quite good that you can see that this can be done. It's not heavy. Only you have to do fast work on this. Hence then check for adequate vertical space availability for receiving thin slab to be laid cast in situ concrete for allowing diaphragm action on hoodie system. Check reinforcing bars for beams are placed correctly. Check reinforcing bars for thin slabs are placed correctly. Means we say check that reinforcing bars for beams are placed correctly, and check that reinforcing bars for thin slab are placed correctly. Check the all services embedments inserts that run through beams as well as through body blocks void cavities are placed intact for working drawings requirements. Be careful for hoodie slab works. Be careful for hoodie slab works, as coordination of services works is a little bit cumbersome and of course a complicated activity in such cases. It's to be noted that slab would be too thin, say about 60 mm only. Therefore, services and beds would not find any room through or within slab portion, as only alternative available is to run these inserts through hoodie blocks cavities. All approvals pertinent, laid services, inserts, blockouts, reinforcements, and location of hoodie blocks and safety of supporting system must be obtained. So you got my point, I think, that I can just blow up more so that you can see a little bit clear. You can see beams are passing through this, smaller beams are passing through these. It's too much. Beams, and these are little secondary and all that. This is what hoodie is, and this was block is, so I close this block now. I will read this once more so that it be clear to everyone. Then we go to other point. Hoodie precast concrete trapezoidal blocks are used to be laid at low blocks to blocks spacing. Checks for all items should be made for various vertical members as described earlier, namely neck columns, suspended slabs, soffits and sides. Ensure for good quality hoodie concrete blocks of defined dimensions are procured. Ensure the cut size blocks to suit site requirements are procured. Ensure that slab formwork is fixed on scaffolding system as usual. Ensure the whole slab area is to be laid in one level without allowing any downstand beams formwork. Check setting out of beams to be laid between or the lines blocks or these blocks lines in both directions. So you can say check for all items should be made for various vertical members as described earlier, namely neck columns, suspended slabs, soffit and sides. Ensure for good quality hoodie concrete blocks of defined dimensions are procured, and ensure that cut size blocks to suit site requirements are produced. Ensure that slab formwork is fixed on scaffolding system as usual. Ensure that whole slab area is to be laid in one level without allowing any downstand beams formwork. Check setting out of beams to be laid between hoodies blocks lines in both directions to be in a conformance to design requirements of workshop and working drawings. Check the hoodie blocks so the blocks works carried out correctly to be laid on set out lines. Check for adequate vertical space available for receiving thin slab to be laid in cast in situ concrete for allowing diaphragm action on hoodie system. Check reinforcing bars for beams are placed correctly, and check reinforcing bars for thin slabs are placed correctly. Check all services, embedments, inserts that run through. Then we can check all services embedded inserts that run through beams as well as through hoodie blocks. Void cavities are placed intact for working drawing requirements. Be careful for hoodie slab works. Yes, coordination of services works is little bit cumbersome and of course a complicated activity in such cases. It's to be noted that slab would be too thin, say about 60 mm only, or maybe 80 mm depending. Therefore, services embeds should be. Then we can say it should be noted that slab would be too thin, say about 60 mm only. Therefore, services embeds could not find any room towards within slab portion, and only alternative available is to run sheets inserts through body blocks cavities. All approvals pertinent late services, inserts, blockouts, reinforcement and location of body blocks, and safety of supporting system must be obtained. Generally, these are used on environmental marine areas. Therefore, epoxy coating is recommended there. Epoxy coating steel bars. Checklist of RCC sloping portion slab works like stair cover. As I just showed to you. I'll keep this now and put out that. As I just now showed to you stair cover, let us see what is that. This is checklist for sloping portion of CC cover slab. It's very rare, but on small slabs it is. I have seen slabs on staircases, covers, and also on some big houses you will find whole slabs inclined like a shed, and that roof is not accessible, so they incline both ends, and that's where it applies. It also applies in various water retaining structures where there are two different levels. For example, you can say sea water basin, big one, so higher level and lower level, as it happens in swimming pool cases, deep end and shallow end, like that. talking of. This is sloping portion, floor slab work like stair cover, and I just now discussed with you about this sketch. I can repeatedly show you, that's no problem. And what's that? This here, I think, every slab is a house plan, ground setting out, house plan, this access grades, house plan, this structural slab, stair cover sloping, that's this one. Also there is one here, and I think what one is that? OD blocks, masonry blocks in UEOD, and is that? So it's same, it's not different. Leave it aside. So now what I was actually trying to show you is the slab, which is here. Again, I will show you. I've seen this. I'll show it to you. I'm just trying to tell you what is that. Now, you see, this is that slab. Actually, this one is that. What it says, this is check that all operations would be done as defined within other operations of RCC suspended slab. That's natural. If these are to some extent involved, provide supporting system of structured scaffolding to sloping requirements per design details, so that system remains stable and stiff. Whatever sections are shown on drawings as such would be provided accordingly. Ensure that sloping portion is rightly carried out to specifications. Requirement to an extent profile of section is concerned with no alteration, with all levels per design remaining intact. Ensure that reinforcing bars are, per requirement, placed in and fixed perfectly. Ensure that whatever services inserts are required to be placed in for fix 1 are done. Do you know fix 1 and fix 2 and fix 3 are there? Of course, I think you should know. And there's a problem I like to say. Fix 1 is services. First attempt when, for example, conduits are fixed for wiring. Fix 2 is further work is done on them, wiring, etc. And third is commissioning and testing, etc. For slope exceeding 30 to 45 degrees, means sometimes up to 30, we take it as normal. Though I think if double is done, it's better, but okay, no problem. If it's high slope, 30 to 45 above, then spatial formwork requirement is made on top for providing top surface profile, which is this one. You may see here. This profile I am talking, this profile, which is here. You can say this is slab to be poured. This is lower, means this is a mandatory, you can't do without that. This one I have not seen this side, this formwork, and then of course scaffolding system below, which is not seen in this. And what I'm saying is I consider the slope is more in this case, so I have to cover with formwork. Opening formwork. This formwork has got many openings, and these openings will be used for purpose of pouring, and cover up is there. Then there is, after doing that, say all these openings I have taken not all out, not shown all, alternatively are shown here. You can use for pouring concrete into them, filling concrete and applying vibrator. But once it is done, you have to close these forms, plug them. This is what says, and then we can say in this case, then for slope exceeding, as I said, 30 to 45 degrees, special formwork requirements made to the top for providing top surface profile, and ensure that top forms are provided and would not move from its position during pouring. Ensure that these forms do have square shaped openings, provisions at suitable spacing in both directions of sloping surface forms, as I showed to you, those opens which will be plugged later on. These openings should cover a whole area of slope to avoid honeycombing or certain voids in hardened concrete. Ensure that sloping form is strong enough to be accessed to and to allow smooth working. Check about openings in formwork which do allow cleaning and concreting pouring operations easily. Make sure that vibrators would be applied easily through these openings. Make sure that vibrator would be applied easily through these openings. Make sure that slope would be cast monolithic with upper, if applicable, and lower flat concrete portion of small projecting portion around. Make sure that opening size formwork plugs shall be available to be placed in after concreting is completed. Make sure that curing would be conveniently effected per specification requirements. The same is a little different, and it is general sloping portion. Also, it's not this I read for you so that I can understand that. Check that all operations would be conducted as defined within other requirements pertinent slabs. Whatever sections are shown on design drawings for preparatory activities would be provided accordingly. Ensure that preparatory works, sloping portion slab, are rightly carried out to specifications requirements applicable for such activities. Ensure that supporting system is well installed or erected to specific scaffolding effective fitness status requirements, and if approved, shop drawings for such work is available must comply with those details. Make sure that required detailed services inserts first fix are duly embedded, inserted in prepared sloping forms. What is that? Make sure that required detailed services inserts first fix are duly embedded, inserted in prepared sloping forms. For slope exceeding 30 to 45 degrees, special formwork requirement is made. Ensure that sections top line formwork are provided and would not move from respective position during pouring. Ensure that sloping portion supports are well anchored and, if so required, well braced. Make sure that temporary platforms per axis and for working area available for sloping portion as well. Ensure that these forms do have square shaped openings Provisions at suitable spacing in both directions of sloping surface forms. Ensure that aforesaid openings shall allow full ease of concrete pouring within specification provisions without causing any hindrance or other issues. These openings should cover over whole area of slope to avoid honeycombing or voids in hardened concrete and ensure that vibration of concrete immediately after pouring would be adequately carried out through these openings. Make sure that required detail services inserts are duly inserted in prepared sloping form, and spacings of these inserts would allow aggregate to be placed in properly. Ensure that sloping form is strong enough to be accessed to and to allow smooth working. Check these operations to allow cleaning and concreting pouring operations easily. Make sure that vibrator would be applied easily over all areas of proposed slab. Make sure that slope would be cast monolithic with upper, if applicable, and lower flat concrete. Make sure the opening size formwork plugs shall be available to be placed in after concreting is completed. Now, make sure the curing would be conveniently affected, and before that make sure the opening size formwork plug shall be available to be placed in after concrete is completed. This is a statement, very simple one. Now I'm going to close these files, and I'll close this file because now we are going to enter into very different world of this item, this very important item, that is maybe you have experience of that, many of you, but here's explanation. It's very important one, I can say. It should be here somewhere. It says tabletop. Tabletop photo. Ha ha. Smile. You're getting something. Smile. You are getting a big structure here. Big structure. This equipment is already there in this structure. This equipment, and it's very heavy vibratory equipment, and you can find this. Though this is, I think it's written something here also. I can't read that. Enjoy this. Where are you? What you are watching at? What you are watching at? maybe I have constructed as such. This must be somewhere you have seen if you had a chance, but generally this must be available in certain restricted areas, not everywhere, because such structures may be available only in certain facilities, plants, which are all restricted areas, or well, I'll show you certain dimensions here which just indicate you only, nothing to do with what I have done. I've done this but not with these dimensions. You can see that, you can see here, though it's not full, it's part only, but you can see this is plan, this is plan, clear in 12 meters width, and it is not given here, I think. Maybe I did not take right. It is somewhere, if this is 12 meters and this is 9.25 meter, so you can see how much is around 20. Same way, it is 2.1 meter more. Now portion below this is foundation within ground, below ground, of course. These are columns, 9 meter high, you can see here, high columns, and this is tabletop. There are voids in that, opening 1, opening 2, opening 3, and these are beams. These are B1, B2, B3, B4, and also this is also beams. This is column C1, C2, C3. Similarly, you can say G1, G3, G1, G3, G1, G2, G3, G4, G5, G6. This is a structural arrangement. This is 15 centimeter down here. This is, I can say, this portion and this portion, 15 or 150 mm. And you can say thickness of this beam is 2.6 meters here, and width of this frame is 12 meters. This is like that. So beam. This is G, indication of another one. These are columns. You can say this is called tabletop, and whole this beam, this tabletop and columns plus foundation in combination whole unit assembly is known as foundation, machine foundation. Here we are talking of compressors, so this is compressor foundation, frankly speaking. You can see this is built one, this is produced one. You cannot see foundation here, but you can see these columns. You can see beams above these columns. These are columns, thick columns according to my understanding, and these are, you can say, beams here. B is a B here. These are C1, C2. These are beams here. These are G beams, and you can say tabletop beam is here. This is 2 point something it was there, right? That is this one. And above, this is different kind of structure here. I'm not saying what I'm telling you, same, and maybe expansion of that somewhere else. Okay, some cantilever here. This just I'm showing you for purpose of indication that This is heavy foundation, machine foundation, expensive foundation. This is concrete world, concrete work. This is not a small compressor I'm talking. This is a very small compressor. I'm talking of very, very, very heavy type of compressors. That's point in that. So now we can say such machines are immense. There are so many such heavy machines, foundations on all plants. If you have a chance to go to see, you can see them. These are very expensive items as far as machine is concerned, and also these concrete bodies, concrete buildings, or concrete, you can say, for performance of shutters and beams. Now we'll go to our topic, and that is heavy compressor foundation, tabletop works. This is different type of concrete. As we said, it says this list applies to heavy structures. This list applies to heavy structures that comprise of components as follows and are collectively named machine foundation tabletops. You may say compressor foundation, foundation below ground in mode of RCC massive block, that is structure number 1. Foundation below ground in mode of RCC massive block, component number 1. Then thick element mode RCC columns on massive block, and so let us say that RCC massive block foundation, then thick element mode RCC columns on massive block with all sides inserted with steel plates welded with tanks, reinforcing bars in RC thick columns starting from base of massive block. Steel provision would come from then you can say after thick elements, thick or massive element above RCC thick columns in mode of heavy RCC beam framing so as to sight on it vibrating machine. Epoxy grouting to be carried out between top of heavy RC beams, framing and base of vibratory equipment. We can see then epoxy grouting. I told you epoxy grouting is carried out with top of heavy RC beams, framing and base of vibratory equipment, and all reinforcement included within square requires to be provided with critical cathodic protection. All reinforcement included within require to be provided with critical cathodic protection. Critical is very important word here. Let's explain what's that. All requirements regarding heavy concrete pouring components must be taken care of to an extent. Class of concrete, class of So you can say all requirements regarding heavy concrete pouring components must be taken care of to an extent class of concrete temperature and differential rising and falling temperatures are concerned. What I've talked in this, as I showed you in a sketch or in photo, this is photo. You have to work like this. You have to produce this, and this is probable section, probable plan, probable only. After all, we are going to produce a big structure of big machine. Machine means vibratory equipment which transfers heavy impact on structure, and also which goes to ground level and work out machines. First is foundation, which is heavy duty foundation, big quantity, cathodically protected. This is massive block which requires temperature controls not only during concrete but also post concrete, which requires different handling of concrete curing, different method. You can say thermal curing. This is very important foundation, and this is having top quantity of concrete among all its components. Then you can say it's massive block concrete, and after that is thick columns on massive block, which is also very difficult to understand and do, and require why thick columns required, what's the reason behind that, I don't understand everything. In these thick columns, you have to take care of verticality because they're exposed members. Of course, that foundation too is exposed in a way, though there's below ground, but there will be many pipes around running if it is an area of plantation, so you have to be careful about that. Now, then massive element above RCC thick column, which is called tabletop, is also heavy structure, and it's very important. Same way as it's very complicated detailing. We have to do that. No way out. Epoxy grouting we have to do, and then reinforcement we have to cover in critical protection, and then heavy pumping, question issue, how to do it. So you can say, well, let us see what is written here. Now what's written says this type of work or structure may apply to cracked gas, propane gas, ethane gas, etc. compressors. Mounting gas compressors, can say tabletop foundations, which are required to be installed within process areas of major plants facilities. Tabletop is top structure, then columns between foundation and tabletop, and foundation plus these columns and this tabletop, if you add, whole is called compressor structure or machine structure. Dimensions of below ground massive block foundation for such tabletops could be 25 meters long, probably 8 to 10 meters wide or more, and 2 meters deep or more, but varies to meet machine capacity requirement. Ensure that design formation level is achieved by required either engineered or structured fill or otherwise, as case may be. This is very important point for everybody to understand, that it's not necessary that you have good formation level. Maybe it is rock sometime, but not necessary. Maybe it is soil, maybe it's no good. So we have to keep in consideration worst scenario. When bearing capacity is too high, this means it can work for this type of truckload. So what is say backfill? If you see soil investigation reports tells that at this excavation level bearing capacity is too low, or you have no reliable soil available there, expensive soil is available which cannot work for such equipment foundation. So what is an alternative left is to remove all bad soil to some level down. It depends on design factors, what soil requires. You can conduct tests and find out strength of that, and then fill material. This is material, granular material, and you have to compact layers of that filled material. It may be few centimeters to few meters, depends, but not ordinary fill. Why should we be worried about that? That's my point. We have to backfill granular material. Engineer fill I'm talking, structural fill I'm talking. It means combined grading based material. Combined grading of various sizes, maybe 40 mm to 20 mm, maybe 20 mm to 10 mm, or maybe 10 mm below. These various filling materials are put one after other and mixed together, and those are laid in layers. A laying time, layer maybe 20 to 100 mm, and worked upon by compactor. Structure fill is answer to such problem. If you don't have good soil, you have to fill in that mix, which I say combined grading in 200 mm and compact it using your roller or whatever best machine you have for rolling. Where these stones are, these stones are. Once you have done it, once you have filled that and you have tested that, up to formation level you are ready to go ahead after the application of whatever is required, waterproofing or membrane and protection of that membrane you can do further. That's all procedure defined. Now you can say, says ensure that design formation level is achieved by required either engineered or structure fill or otherwise as case may be. So fill is available and you are ready. Ensure that design formation level is achieved by required either engineered or structure fill or otherwise as case may be. And then you can say ensure that achieved prepared formation level is duly load tested and approved. Ensure that all precautionary measures required for such involved in working areas for ingress say cold, change weather. Ensure that achieved prepared formation level is duly tested and approved. Ensure that all precautionary measures required for such involved and working stress for ingress, egress and other mandatory safety measures are adopted. Again, make sure that all precautionary measures required for such involved and working stresses for ingress, working areas for ingress and egress or other mandatory safety requirements are adopted. How we have to go in, how to come out, what safety measures we have to adopt, we have to keep in touch all the time. Yes. Then onwards can say after taking measures regarding safety from every viewpoint, you have to carry out, after carry out, you can say blinding concrete layer according to procedure we talked before, and you have to apply, we have to ensure, means you have to do blinding layer and apply concrete protection on that, which is further protected according to procedures. It says ensure application of concrete protection mechanism if so required is carried out per manufacturer's instructions and only. So it says ensure blinding concrete layer is well laid and concrete protection applied accordingly. Ensure application of concrete protection mechanism, if so required, is carried out per manufacturer's instruction and duly approved method statement. Ensure shop fabricated reinforcing bars, of course uncoated, are received for installation. Epoxy coated bars shall not be included due to cathodic protection is to be installed. Ensure that these cut and bent reinforcing bars are rightly tagged for design reference identification. Check about on-site fabrication of forms smoothly, ongoing for making vertical sides. Ensure whether or not vacuum test is conducted for concrete protection membrane that has been applied, so that formworks plates may not damage this if no mortar based horizontal layer is applied upon membrane. Should formworks fabricated plates be proprietary form, these should comply with manufacturer's drawings. Sometimes what happens, you want to hire certain customized formwork for your job, and there are certain specific specialists in that area. You can ask them to pay for this. Will pay for that your cost or higher charges or whatever it is. No rate can be kept secret. After that, you can say, or it says, should formworks fabricated plates be proprietary form, this should come from comply to manufacturer's drawings requirements. Check that marking is made on prepared foundations for location of reinforcing bars. Check that marking is made on prepared foundations for location of reinforcing bars. Ensure that delivered reinforcing heavy bars are placed properly. Ensure that delivered reinforcing heavy bars are placed properly to design requirements, while upper heavy bars are supported on strong chairs of considerable size, rebar say 25 tall. Keep in consideration that this is generally major foundation where enough vertical space would be available. Ensure that the reinforcing bars or start the bars of heavy RCC columns or RCC walls, if so designed, are well placed intact into foundation portion. So there are 2 points together. Keep in consideration that this is generally major foundation where enough vertical space would be available within placed main reinforcing bars around section of massive block. Ensure that reinforcing bars or starter bars of heavy RCC columns or RCC walls, if so designed, are well placed intact into foundation portion. Mind that these bars are always heavy as well. I say ensure reinforcing bars, star bars, heavy RC columns, or RC walls if so designed, well placed, intact to foundation portion. Mind these bars are always heavy as well. Sometimes bending of these reinforcing bars is not permitted. It requires spatial positioning of these reinforcing bars complying per design details. Since heavy quantity of reinforcing bars is required for such foundation, heavy, deeper chairs are required at various locations depending on expected working loads. You know what I mean? I say in foundation you have to put certain bars, means main bars of foundation, which are column bars, and sometimes you have to put starter bars in beginning and later on, or you can't take full. If you take full it's okay, but it's 9 meters, say 10 meters above foundation and 2 meters in foundation, 11 and 12, 13 we say. In that case you can't take full bar in one go, so what to do is to start a bar in the beginning. This starter bar should be the main location, means where it is going to be in column, should be that location. So what we do in this reinforcement of columns, we provide starter bars, but these starter bars should not be so we have to provide starter bars in correct location. How to do that? That's the important point. What we have to do that? These are big die bars. So in drawings I noted that there was a separate starter bar was in separate location just adjacent to requirement, and main bars were in right location, main bars and upper bars. But these days there are so many ways. It's not necessary that we provide overlaps. It's not mandatory. There are many ways, those are in compression, but we have couplers with us. Couplers can be provided, compression couplers, after testing. We can go many ways because these are heavy reinforcing bars, 32 mm in some cases, 25 in some cases, depending on resistance, depending on requirement. So in those days, main bars were kept in right position, and starter bar were little shifted on other side, so that, and accordingly we had to do arrangements. In drawings it is clearly mentioned where should the starter bar be located and there should be this bar. So that was that. Now I think completely it is changed, but we have to think. That's our job. If we can't think, means we can't do. Engineering is thinking, as I said. Engineering is always thinking. It's nowhere other than that. Engineering is thinking. If we don't think, we lose a lot. So, which that means we have to think and think and think and find solutions, and that's job of engineering. So it says that mind that these bars are always heavy as well, and these are ensure that reinforcing bars or starter bars of heavy RC columns or RC walls, if so designed or well placed intact into foundation portion. Mind these bars are always heavy. Sometimes bending of these reinforcing bars is not permitted. If it requires spatial positioning of these reinforcing bars, complying per design details, since heavy quantity of reinforcing bars is required for each foundation. Heavy deeper chairs are required at various locations depending on expected working loads. Ensure the workers who do work safely within space available. Check fabricated forms or plates. Check fabricated forms, plates or sides are in compliance with dimensions of foundation size. These shall be fabricated many such plates to be erected on all sides. Due to fact that width of plywood is just 1.24 meter, whereas longer side of ply may be enough to cover depth of foundation concrete. Ensure that forms are erected in sequence, connected and well supported. Ensure that forms, plates, sequential panel edges are well secured. Ensure that forms, plates, corner panels are well secured. Ensure that access to inside of concrete area, forms, plates being safe. Ensure alignments and plumb controls measures for forms, plates are correct and within possible limits. Ensure inclined supports are fixed to necessary requirement. Ensure concrete spaces are installed to meet reinforcing bars requirement. Ensure certain bars on top are allowed to be fixed later so that convenient entry is allowed to descend to lower bars. Ensure that sacrificial nodes are arranged and their interface connections to foundation reinforcing bars are tied up using galvanized wires or cables clamped with stainless steel C-clamps for cathodic protection. This type of foundation requires, wait a minute, ensure the sacrificial nodes uh, are arranged and their interface connections to foundation reinforcing bars are tied up using galvanized wires or cables clamped with stainless steel C-clamps for cathodic protection. Ensure the sacrificial anodes required to be inserted in are securely welded. Inspection of this anode has to be done by going to lower reinforcement mesh. Ensure electrical continuity test is conducted properly on all reinforcing bars. This type of foundation requires critical cathodic protection comprising of stainless steel C-clamps fixed on all reinforcing bars and duly tied up GI wires, tendons. Each bar must be tested for electrical continuity. Each bar must be tested for electrical continuity, and if some problem exists, tightening of stainless steel clamps and galvanized iron tendon be properly conducted. Numbers of such cathodic protection depends on designs and carried out accordingly. Sacrificial anode is provided at bottom and at top. So sacrificial anode is provided at bottom and at top somewhere on some thick column reinforcing bars depending on design requirement, which must be adequately welded and approved. So if you say in the last one, each bar must be tested for electrical continuity, and if some problem exists, tightening of stainless steel clamps and GI tendon be properly conducted. Numbers of such cathodic protection depends on designs and carried out accordingly. Sacrificial anode is provided to provide bottom and top somewhere on some thick column reinforcing bars depending on design requirements, which must be adequately welded and approved. All works must be inspected and approved prior to pouring. All plans about how to go ahead for concrete pouring must be charted out indicatively as follows. That is, quantify concrete volume and plan. Quantify concrete volume and plan for pouring method that has to be approved. Plan for concrete ordering sequence, plan for pouring working hours, plan for workers deployment, plan for on-site testing, plan for stepping management of pouring, plan for curing arrangements, plan for thermal controls, plan for working access onto top area, plan for a standby construction joint, form work on or stop step arrangement to meet certain dam emergency during pouring duration. Foregoing plans shall be written in form of method statement, a professional document for conducting or carrying out concreting pour, defining all details and necessary sketches for proposed circulation from commencement of pour to completion of pour, and proposed curing follow-up procedure which demands thermal curing activity in addition to normal curing post. Thermal curing activity is applied for massive block foundation concrete curing when water curing is not conducted directly. Principle behind thermal curing states that evaporation is not permitted from concrete. Chemical reaction. Evaporation is not permitted from concrete chemical reaction that should be retained within concrete. Whatever heat is generated, that remains within concrete volume for a couple of days until temperature comes to normal requirement. This means we are not going to cure water using water. This is massive block. We are not going to use water for curing. We are going to use heat generated for curing. That heat we generate won't be allowed to evaporate. That shall remain within concrete mass, and hence there shall be no need, no requirement of replacement of lost heat. That is done by water, and that's what we say. Whatever heat is generated, that remains within concrete volume for a couple of days until temperature comes to normal requirement. Though supplement cementing materials are used to replace ordinary Portland cement up to 70%, even then chemical reactionary heat is generated, but not with that rapid speed as is affected when OPC is used. Though sulfate resisting cement could also be used depending on soil composition, yet supplementing cementing materials, SCMs fulfill sulfate resisting cement requirement. Supplementing cementing materials are GGBS, PFA and MS. GGBS, PFA and MS, glass granulated blast furnace slag, ground is the gist of the ground. So ground granulated blast furnace slag, PFA is pulverized fly ash, and MS microsilica or silica fumes. GGBS is generally included up to 70% of OPC replacement because it gives better grinding control and to certain major extent cracking due to high temperature. High temperature in case is contained. PFA is then you can see GGBS generally, I said again, GGBS generally includes 70% OPC replacement because it gives better grinding control to certain major extent cracking due to high temperature. Shrinkage is contained. PFA doesn't provide that level of freedom as GGBS does. Of course, initial setting time is delayed due to GGBS inclusion, but ultimate strength remains same as is achieved by OPC inclusion. Moreover, GGBS is pro-environment material because it can reduce carbon dioxide generation up to 80% in comparison to OPC. 1 ton cement generates about 1 ton carbon dioxide. So we have gone through this system, and now I think it's time to close this talk. You can see this photo of built one, some machine foundation. They're not that I'm talking, just for reference, what's stick column, what's the framing, and what's foundation. I try to show you from, I could search from web and put in there for your reference, and also dimensions of this certainly. And this is and this quality, as we said, every day, this is our life. Quality is our life. If you don't understand this, we make mistakes. It's really wonderful if we define quality ourselves, add to that more and more strength, only then we can say it is good one. So what I said, you can say, meanwhile, we close it now. It's, I think, 3, can say, thank you very much, I should say, right? We'll talk again, we'll continue with this next time. Thank you very much.